April 16th, 2024. In one of the driest regions on Earth, Dubai, the capital of luxury and technology, was submerged. In just 24 hours, the region received 254 millimeters of rain. That is equal to the total rainfall the area usually gets in about 2 years. Airports shut down, skyscraper lobbies turned into rivers, and million-dollar cars floated away like toys. The world was in shock. But behind the scenes, a far more unsettling question was being whispered. Did they do this? Let's put this aside for now and focus on the UAE's neighbor, Saudi Arabia. We will come back to this later. This is the geographical reality of Saudi Arabia. It is a nation the size of Western Europe, yet it possesses no permanent rivers, no lakes, no natural forests. 95% of the landmass is desert. For millennia, civilization here has been defined by brutal constraint, the scarcity of water. And yet, in the face of this hydrological emptiness, the kingdom has announced an objective that seems on paper to be mathematically impossible. Under the Saudi Green Initiative, part of the massive Vision 2030 transformation plan, the government has pledged to plant 10 billion trees. The goal is to green the country, halt soil erosion, sequester carbon, and improve the quality of life. This demand piles onto an existing crisis. Satellite imagery already displays thousands of center pivot fields scattered across the desert, illustrating the kingdom's effort to expand agriculture in one of the driest regions on Earth. This agricultural drive consumes over 80% of the kingdom's water supply, rapidly draining non-renewable fossil aquifers that took millennia to fill. Adding 10 billion trees to this equation seems hydrologically impossible. But with 95% of its land currently desert, where will Saudi Arabia find the water necessary to grow 10 billion trees? It is said that Saudi Arabia is relying on cloud seeding as one component of its long-term water strategy. But this raises big questions. Can Saudi Arabia actually solve these massive targets through cloud seeding? How effective is this technology in reality? And does making it rain on your own land mean you are stealing water from your neighbors? To address the kingdom's chronic water limitations and support its broader environmental ambitions, the government introduced the Regional Cloud Seeding Program. The initiative aims to enhance annual rainfall levels, potentially by as much as 20%, as a supplementary tool to boost groundwater recharge and sustain large-scale greening efforts. Saudi Arabia officially started this program in 2022. In 2023 alone, they carried out more than 400 flights in 6 different regions, stayed in the air for 1,300 hours, and fired thousands of seeding flares. So, how does this cloud seeding actually work? The logic is actually quite simple. For a cloud to release rain, water vapor needs small particles, or nuclei, to cling to. In nature, dust or pollen does this job. Saudi engineers are speeding up nature's work. In the state-of-the-art meteorology center in Riyadh, massive radars scan the sky 24 hours a day. The moment a wet cloud mass with rain potential but not enough density is detected, the alarm is sounded. Specially equipped aircraft, usually King Air or Cessna models, take off and dive straight into the heart of the cloud. At the perfect moment, they fire flares mounted under their wings. These flares release silver iodide. The molecular structure of silver iodide is incredibly similar to ice crystals. Supercooled water droplets inside the cloud mistake these silver iodide particles for ice and stick to them. As they stick, they grow. As they grow, they get heavier. And eventually, they succumb to gravity and fall. As they fall, they melt in the warmer air and turn into rain. So, after all this time in the air, what has Saudi Arabia actually gained? It is estimated that cloud seeding operations produced a total of 4 billion cubic meters of rainwater in 2023. However, since Saudi Arabia has not fully released detailed rainfall reports for the 2020 to 2025 period, it is impossible to create a precise graph showing exactly how much rainfall increased year over year. Across the Gulf, there has been a recorded trend of increasing average rainfall in recent years. Part of this is due to climate change, which is causing more frequent and intense storm systems. Therefore, it is not accurate to attribute this entirely to cloud seeding. The Saudi National Center for Meteorology reports detecting localized increases in rainfall where the program is active, but they do not provide a definitive ratio regarding how much of this is caused by cloud seeding. At this point, we need to talk about what cloud seeding cannot do. It is simply providing the key to unlock the water that is already there. It facilitates the merging of water droplets inside the cloud, turning them into raindrops. If the sky is dry or there are no clouds, seeding is useless. This is the most fundamental limitation of the technology, and the World Meteorological Organization emphasizes this exact point. Seeding without clouds is meaningless. Seeding affects microphysical processes within the cloud. It cannot control macro-scale weather dynamics like starting a storm system, shifting the jet stream, or steering regional atmospheric circulation. Localized increases and effects over a few kilometers are possible. However, massive floods and extreme precipitation are almost always the result of large-scale meteorological systems. Returning to the Dubai example, meteorologists state that linking such heavy rainfall to seeding lacks any scientific basis. So, contrary to popular belief, the cause of the Dubai flood was not cloud seeding. The Royal Meteorological Society identified the cause as a mesoscale convective system, a massive storm structure fueled by extreme atmospheric moisture and heat. Reports from international outlets like The Guardian and The Washington Post, citing climate scientists, emphasize that cloud seeding simply does not have the power to generate rainfall of this magnitude or intensity. The flood was likely a result of natural atmospheric dynamics, amplified by climate change. Then there's the widespread belief that cloud seeding allows one country to steal rain from its neighbors. While it's theoretically possible, in practice, it's not that black and white. The logic behind this claim is simple. Atmospheric water is finite. So, if country A squeezes a cloud over its territory before it reaches country B, that cloud arrives dry. However, atmospheric scientists argue that this concept of rain theft is largely exaggerated. Clouds are not bags that empty completely once it rains. A single cloud contains thousands of tons of water vapor. The amount of rainfall is determined by cloud size, wind shear, temperature differences, moisture influx, and vertical air movement. And cloud seeding can't actually drain a cloud completely. In the best-case scenario, it only boosts rainfall by about 10 to 20%. This means the vast majority of the moisture stays in the cloud and continues on its path. In other words, a cloud might rain a bit sooner due to seeding, but it doesn't empty out completely. Moisture reaccumulates inside the cloud within minutes. The same system can still produce rain as it moves toward a neighboring country. The atmosphere is a continuously fed system. A single seeding operation cannot cut off the precipitation cycle. Therefore, the idea that seeding in one country stops a cloud that was likely to go to a neighbor is highly questionable on an atmospheric scale. So, if cloud seeding doesn't have the massive impact predicted, how will Saudi Arabia water 10 billion trees? Trees mean water. A sapling needs at least 200 to 500 liters a year, and a mature tree needs several tons. Even if we assume an annual average of 1,000 liters, for 10 billion trees, that means 10 trillion liters of water per year. That is more than half of Saudi Arabia's total annual water consumption. What does Saudi Arabia have besides cloud seeding? The short answer: seawater desalination. Gulf countries today possess the world's largest desalination capacity. Saudi Arabia is also investing heavily in this area and increasing its capacity. Desalination is the country's secure path to water. However, the bill for desalination is steep. High energy consumption, costly facilities, and environmental impacts like brine concentration and waste discharge create problems that must be managed. In short, watering 10 billion trees means not just planting saplings, but building dozens of new desalination plants, energy investments, and a massive distribution infrastructure. By the way, we also have a video about Israel, which performs the most effective seawater desalination, meeting 80% of its drinking water needs and enabling desert agriculture. We recommend you check that out as well. From a water perspective, the 10 billion tree target is possible, but not realistic. In fact, according to publicly disclosed data, over 100 million trees and shrubs have been planted in the country since 2021, and 118,000 hectares of degraded land have been included in restoration programs. Some were completely replanted, some encouraged for natural regeneration, and some placed under protection status to remove human impact. So, yes, there is real movement on the ground. However, these figures show that only about 1.5% of the target has been completed so far. Furthermore, desert ecosystems are extremely challenging for the long-term survival rate of saplings planted in low-moisture areas. Greening on a scale of 10 billion requires not just water, but a massive operation involving shading, soil enrichment, maintenance, protection, and species selection. In short, the 10 billion target might be numerically ambitious, but it is a framework symbolizing the country's will for ecological transformation. What has been done so far is not to be underestimated. Rehabilitating hundreds of thousands of hectares in the middle of the desert, planting millions of saplings, establishing new irrigation and water management systems. This is not a project that will finish tomorrow. It is a transformation that will take years, perhaps even generations. It is extremely challenging scientifically, logistically, and economically. Therefore, this goal is on one hand, a project advancing with real steps, and on the other, a vision still carrying major question marks, constantly tested by the realities of geography. We are waiting for your thoughts in the comments. Don't forget to subscribe to our channel. See you in the next video.